You flip a light switch and the room gets bright. You plug in your phone charger and somehow electricity flows into your battery. But what's actually happening with all that invisible energy stuff? Today, I'll explain volts, watts, and amps to you like you're 5 years old. And by the end, you'll understand the difference between these three electrical mysteries without your brain melting. Think of electricity like water flowing through pipes in your house. This isn't a perfect comparison, but it's close enough to help you understand what's going on. Just like water moves through pipes to get to your sink, electricity moves through wires to get to your devices. But instead of water, it's tiny invisible particles called electrons that are moving around. And these electrons are so small, you can't see them, even with the strongest magnifying glass in the world. Now, let's talk about volts first. Volts are like the pressure of water coming out of your garden hose. Imagine you have a water slide at a playground. If the slide is really tall and steep, the water rushes down super fast because gravity is pushing it hard. If the slide is short and not very steep, the water just kind of rolls down slowly. Voltage is like the height and steepness of that slide for electrons. High voltage means there's a really strong push, making the electrons want to zoom through the wire. Low voltage means that there's just a gentle nudge. The electricity that comes to your house has a voltage of about 120 volts in most places. That's like having a pretty tall water slide for electrons. It's enough push to make them move through your wires and power your stuff, but it's not so much that it's dangerous if you're careful. Well, it can still be dangerous, so don't go sticking forks in electrical outlets. But it's not like a super high voltage power line that you see up on those tall towers, which do have thousands and thousands of volts. Your phone doesn't need a big push to charge its battery, it just needs a small, steady push. Now, let's talk about amps, which is short for amperes. If volts are like the pressure or push of water, then amps are like how much water is actually flowing through the pipe. You could have really high water pressure, but if you're trying to push that water through a tiny straw, not much water is actually going to come out. Or you could have low pressure but a really wide pipe and lots of water flows through. Amps measure how many of those tiny invisible electrons are actually moving through the wire at any given moment. Most of the things in your house use different amount of amps. A small LED light bulb might only use about 0.1 amps. That's like having just a few electrons trickling through the wire. But a hairdryer might use 10 or 15 amps. That's like having a whole parade of electrons marching through the wire. Your microwave might use even more, like 20 amps. That's like having a stampede of electrons rushing through to make those invisible wiggling fingers we talked about before. The wires in your house are designed to handle a certain number of amps safely. That's why houses have circuit breakers or fuses. They're like safety valves that shut off the electricity if too many amps try to flow through all at once. Now, here's where it gets interesting. Watts are different from both volts and amps. Watts measure how much electrical energy is actually being used or converted into something else, like light or heat or motion. Think of watts like measuring how much work is actually getting done. Now, let's get back to our water analogy. Imagine you have a water wheel, like the kind they used to have at old mills. The water flows over the wheel and makes it spin, and that spinning motion can be used to grind grain or power other machines. The voltage is like how hard the water is pushing. The amps are like how much water is flowing, but the watts would be like measuring how much actual work the water wheel is doing. How fast is it spinning? How much grain is it grinding? That's the watts. In electricity, watts tells you how much power a device is actually using. A small LED light bulb might use 10 watts. That means it's converting 10 watts of electrical energy into light energy every second. A hairdryer might use 1,500 watts. That's a lot more electrical energy being converted into heat and air movement. Your microwave might use 1,000 watts or more, converting electrical energy into those invisible wiggling fingers that make your food hot. Here's a really important thing to understand about the relationship between volts, amps, and watts. They're all connected by a simple math equation. Volts times amps equals watts, or as math people like to write it, V times A equals W. This means if you know any two of these numbers, you can figure out the third one. Let's try an example. Say you have a light bulb that uses 60 watts and you know your house voltage is 120 volts. How many amps is that light bulb using? Well, if volts times amps equals watts, then amps equals watts divided by volts. So 60 watts divided by 120 volts equals 0.5 amps. That light bulb is using half an amp of current. Or let's say you have a device that uses 2 amps of current at 120 volts. How many watts is it using? 120 volts times 2 amps equals 240 watts. You see how that works? This relationship helps explain why some things work the way they do. Remember how your phone charger takes 120 volts from your wall and turns it into 5 volts from your phone? Well, your phone might need 10 watts of power to charge. At 120 volts, that would only need about 0.08 amps. But at 5 volts, it needs 2 amps. Same amount of power, just delivered differently. This is also why high voltage power lines are used to transport electricity over long distances. It's more efficient to send electricity at really high voltage and low amps than it is to send it at low voltage and high amps. Remember, the wires themselves have resistance, kind of like friction. When electrons flow through a wire, some of their energy gets converted to heat because of the resistance. And high watts means a lot of energy is being converted, which often means a lot of heat is being generated. But in normal, everyday situations with properly working electrical devices, you don't need to worry about any of this. The engineers who designed your phone charger and your microwave and your light bulbs have already figured out all the safe combinations of volts, amps, and watts. They've built in safety features and designed everything to work together properly. You might have noticed that many electrical devices have labels on them that list their voltage, amperage, and wattage requirements. And now you know what those numbers mean. The voltage tells you what kind of electrical pressure the device needs. The amperage tells you how many electrons need to flow through it. And the wattage tells you how much electrical energy it will convert into other forms of energy, like light, heat, or motion. Different countries around the world use different standard voltages. That's why when you travel to other countries, you sometimes need special adapters or converters for your electronic devices. The charger has special circuits inside that automatically adjust to whatever voltage is being provided. Now, you might wonder why we have these different measurements at all. I mean, why not just have one number that tells you everything about electricity? Well, it's because electricity can behave in different ways depending on what you're trying to do with it. Sometimes you need high voltage but low amps, like in your TV tube. Sometimes you need low voltage but high amps, like when jump-starting a car battery. And sometimes you need to know exactly how much total energy is being used, which is where watts come in. And you might want to know how much total energy it's using to do work, like climbing a hill, which is like watts. Understanding these concepts can help you make better decisions about the electrical devices that you're using. For example, if you're trying to save money on your electric bill, you want to pay attention to watts, because that's what you're actually paying for. The electric company charges you for the total amount of electrical energy that you use, measured in kilowatt hours. And a kilowatt is 1,000 watts, and a kilowatt hour is using 1,000 watts for 1 hour. So, if you have a 100 watt light bulb that you leave on for 10 hours, that's 1,000 watt hours, or 1 kilowatt hour. If you have a 1,000 watt microwave that you use for 1 hour total during the month, that's also 1 kilowatt hour. Same amount of energy, just used differently. This is why LED light bulbs are so much more efficient than old incandescent light bulbs. An old 60 watt incandescent bulb and a 10 watt LED bulb might produce the same amount of light, but the LED uses 6 times less electrical energy. Over time, that adds up to significant savings on your electric bill. So, let's recap this whole electrical adventure. Volts are like the pressure or push that makes electrons want to move through wires. Watts are like how much electrical energy is actually being used or converted into other forms of energy. They're all related by the simple equation. Volts times amps equals watts. Now go forth and impress people with your newfound electrical wisdom.